Oh, let's see. Hey, Tech Rabbit here again. Let's see if I can do. Sorry about this button. There. Yeah, we've been going through different ways to control this laser diode, which is very, very common if one orders from the usual places. So now I thought I'd go through using a power MOSFET to actually control it. And set up a bit of a circuit here. Let's see. This one. So I actually wired it up here. A simple circuit. We have the laser diode here, and then we have MOSFET is here. The control signal coming in here is from the signal generator, and then I'm measuring both the control signal and the voltage, because the laser diode's been pulled to ground, so I'm basically just measuring that. So if I increase, we run it at like 50 Hertz. Yeah, we can see we got here's the control signal, and then here's the the other side of it doesn't go up to 5 volts due to the fact that you got a voltage drop when the MOSFET closes. Here you can see it's being pulled down to ground, and the reason I'm measuring this point is that you get this very typical behavior from that if you use the, let's see if we go back to here. See here you have the gate to source. I mean, they say that they are like many MOSFETs are like, you know, can be controlled from logical signals like 5 volt logic, or even in some cases 3.3, but that's a little bit on the line of not really being the case in most cases. They do like to have a gate voltage that's higher than 5 volts, so to make the MOSFET open correctly, and to get the pull down to be as close to 0 volts as possible, then I've had to actually increase the control signal to 6 volts. As you hear on the oscilloscope, we can see that it's 3 divisions. So it's so I'm using a 6 volt signal. Yeah, so that also can work to control it with a MOSFET. Then of course how fast one can go is also, yeah, there are objective ways to analyze it. Or then we just try something, so I will increase the frequency. Oops, wait. Hit the wrong button. So if we say like 100 kilohertz, let's see now. So it doesn't look that bad. And we can increase it to 200, 200, 300. Just a sec. Let me start seeing a little bit of malforming of the control signal. Actually seems to be less delay between the control signal and the actual signal. Oh yeah, 300. Oh, that is yeah, that is 300 kilohertz. That's not that bad. Then we can just free that up again. 4, 5, 6. Let's see when it gets unusable. When it gets to like a megahertz, then I think it's starting to get a little bit, suspect as to. And then have to repeat the other issue that we don't know what the optical performance is. So even if I'm running at a megahertz here, if the light is actually switching on and off at a megahertz, I don't have the measurement equipment to actually validate that the actual laser signal is reproducing this control signal in any real meaningful way. Might be I was thinking of maybe following it up with a little bit of a video about that, capturing the laser signal and analyzing it. But I mean, the circuit isn't that complicated. So the source of the MOSFET is just grounded, and you have the contrast signal between the gate and the source, and then the drain just basically pulls down the laser diode, and the laser diode has direct source voltage feed. Which now the good thing with them, so one can actually use, in this case I was able to use 5 volts as the feed voltage for the LED, for the laser. And the only problem being is the MOSFET grading, gate source voltage. I don't know. It needs to be higher than 5 volts, even if they say it should work with 5 in some cases. It does work. It's just that it doesn't open the MOSFET completely. So you get a bit of an offset from the ground plane. So then you could compensate by increasing the supply voltage to the actual laser diode. So anyway, that was fun. Now we've gone through all the, I would think, the three most common ways of controlling the laser diode. So we started with the relay, and then we tried a transistor, and now with a MOSFET. I mean, there are of course probably some integrated circuits that can have enough power to drive, but they're probably internally integrated MOSFETs most likely. So they have like a power pin so they can drive more current. But I think that for simple prototyping, this would be okay. So, okay, now I'll just wrap this one up. Bit of a short introduction into MOSFET control of the laser diode. So, see you in the next one.